Hey guys, welcome back to the 99th percentile. Just to start off, I got an 18 on the practice science SAT, and then on my real one, I got a 36, and I did this all under 2 weeks. So I just kind of want to walk through the thought process that I had during the test so you guys get a feel of what you should be thinking like if you want that perfect 36. And so in order to do that, I've pulled up a 10-question ACT science practice test. I've heard this one's pretty hard. I haven't done it personally, but let's just see how it goes, and I'll be thinking aloud so you guys can see how I think during the actual tests. Okay, so a bunch of graphs, words, skipping all of that, okay? That's the number one tip. Which set of data best supports the claim that field A has lower soil quality than field B? Okay, I'm just remembering lower. This is like another tip that I have is whenever you're doing these like ACT tests, specifically the science, they're gonna have some keywords. Just kind of remember that. Alright, so lower. Let's start here. Is field A lower? It looks like it's higher, which I mean crop yield's probably better. We're gonna kick this one out. SOM, what on earth is that? Okay, well A has higher SOM. What is SOM though? Oh, right here. Okay, so if it's higher, that means it's excellent soil quality rating. Alright, so A is better in this one too. Alright, A is a dark one. Hey, it still looks like A is better. Okay, bulk density. I mean, if it's more dense, the soil is better. I would think so. I mean, I'm kind of stumped on this, so that means I'm going to have to look through this, like the paragraphs. You don't have to read them, just kind of skim through them. I see 1.33 something. Oh, so it says if it's above 1.33, then it's bad soil quality. Looks like A is above 1.33. Oh, so it does have bad soil quality. So that would be figure 1. That's the right answer. If 8 tons or fewer in crop yields were considered a failed harvest, in which year and in which field would there have been a failed harvest? So 8 tons or fewer crop yield. Alright, so we'll start with 8 tons and we'll just kind of draw a line across anything that's below or right at this line. So that would be this one right here, which is B, year 5. Suppose a new crop rotation for field B included a bunch of random plants. The SOM of this field will most likely change in which of the following ways? Okay, so it's saying that we're adding like deep-rooted and high-residue crops. I'm not sure what that means, so we're going to have to go back to the words. Just kind of skim through it and try to match stuff. I'm not seeing anything about those specific like plant types. Interesting. Alright, let's go back and look through again. Bulk density. Oh, okay, here. It says that SOM is a measure of the active organic content. So if SOM is higher, that means that there's more active organic matter, which means plants. So that means the SOM is going to be higher. So we can cross out A and B. So SOM is going to increase because soil quality is likely to increase. That relationship is exemplified in table 1, so we know that's right. Alright. Based on figures 1 and 2, consider the average bulk density and the average crop yields for field A and B. Which site had the lower average crop yield and which site had the higher average bulk density? Let's start with lower average crop yield. Crop yield, B, the lighter one. Alright, so we can cross out F and H. And then the other thing is which one had a higher bulk density? A. Alright, so it's B for lower crop yield and A for higher bulk density. As soil quality improves, the number of earthworms increases. Students hypothesize that more earthworms will be found in field B. Is this consistent with table 2 basically? Okay. B has a lower SOM, so it actually has a worse soil quality rating, meaning it would have less earthworms. So we know that it's not A or B. I mean, you can cross them out if you want. I just kind of remember them, but yeah, you can cross them out if you want. So based on the SOM, field B has a soil quality rating of poor. Let's just go and check that, because I feel like that was not the case. So 0.28. Oh, that's fair, yeah, so it's not poor. That means we also cross out this one, and we know it has to be D. Alright, we have the new questions, like 5 more or something. I'm not reading any of this. Okay, based on table 1, if the amount of whatever that is produced on day 9 had been measured for the salt solution, it would most likely have been. Okay, go back to table 1. Day 9, we don't have that. Salt solution. Okay, so it increases. So it would have to be greater than 1.84 for day 9 for this pattern to continue. Oh, that's an option. Perfect. And the experiment shown in Table 1 and Figure 1, by measuring the rate at which whatever that is was formed every day, the experimenters could also measure the rate at which... Okay, so I think it's saying what else is formed by this, because if there's formed too, then we can kind of equate them. Oh, scrolling up too far. Oh, right here is a chemical equation, and it looks like another one of the products is H2. And this is just kind of the small chemistry knowledge you need for the ACT stuff. Like before the arrow is the reactants, the stuff on the right is the products. So H2 is also produced. And then consider the amount of blah 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 produced by the salt solution on day 2. The water buffer to H produced. Okay, so first we need to figure out what happened to the salt solution on day 2. 0.56, and we're going to draw a line from 0.56 to the 10. Wait, where's the 10? 10 pH is a solid line. 0.56 is like somewhere around there. Pretend that line's straight. It almost looks like it's hitting it at 8. That's not an answer, so it has to be 10 because that's actually going upwards. So 10 is the answer. According to Table 1, what was the amount of blah 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 produced by the sugar solution from the time day 6 to day 8? This is just math, I would assume. Sugar, day 6 to day 8, yeah, 0.08. If you can't do that mental math, you can just kind of write it on paper and figure it out, or you can just add it stuff to day 6 until you get the measured amount in day 8. I know it's hard to do the math when you're actually in the testing situation. Based on Table 1, which graph best shows how the amount of blah 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 produced by the sugar solution changes over time? Sugar solution, it's increasing because it starts at 0, so we know it can't be G or J. Can cross those out. We have H and F left. Let's go up. So it's increasing by around 0.05 every day. Yeah, and it's still increasing here, so we know that it's not going to stay the same like H shows, so it has to be F. Okay, let's check our answers. And we got them all right, and I'm pretty sure we did that like pretty fast as well. And you would probably be faster without talking and reading the questions aloud. But there we go, guys. If you have any questions, put them in the comments and like and subscribe. Thanks.